Good afternoon, everyone. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings. We are broadcasting live from Apple Valley, California.
Yep, and we're still talking science and technology.
Yes, sir. A research team led by Dr. Bon-Cheol Ku and Dr. Seo Gyun Kim from the Carbon Composite Materials Research Center at the Korea Institute of Science and Technology, KIST, along with Professor Yuanzhe Piao of Seoul National University, has developed a high-performance supercapacitor that may represent the next gen of energy storage. Their research was reported on January 27, 2025 in Composites Part B, Engineering. Would you like to know more?
Okay, so I know what a capacitor is. It's like a
It stores
power
up
storage or a battery.
energy. Yep.
Yep. What is a supercapacitor?
Uh,
Super.
able to do it on a large scale.
All right. Their breakthrough addresses key limitations of current supercapacitors by using an advanced fiber structure made from single-walled carbon nanotubes, and we've talked about nanotubes a lot, and the conductive polymer polyaniline. Supercapacitors charge faster and often offer higher power density than traditional batteries, with minimal performance loss even after tens of thousands of charging cycles. However, there are lower energy density limits how long they can operate, which has made them less practical for extended use applications like electric vehicles and drones. Okay, so I know I've dealt with capacitors in compressors, generators, air conditioning condensers. So I wonder if these supercapacitors could take the place of some of the capacitors in some of those. But maybe that wouldn't apply. Maybe we'll read on and we'll figure out what we're going to use these for.
Well, laptops and computers, they use capacitors, so that could be possible.
Then now they use they're just a smaller scale capacitor.
Yeah.
Gotcha.
Or
Okay.
superstations could help with not superstations. What are those stations called with the electric substations?
Oh, substation.
Substations, yeah, it could be used there. To address this challenge, the researchers chemically bonded single-walled carbon nanotubes, known for the high conductivity, with polyaniline, a low-cost and easily processed conductive polymer. By combining these materials at the nanoscale, really tiny, they created a complex fiber structure that improves the movement of both electrons and ions. This results in a supercapacitor capable of storing more energy and releasing it more quickly.
The new supercapacitor has demonstrated stable performance through over 100,000 charge and discharge cycles and remains effective even in high voltage environments. Because of its durability and efficiency, the technology can serve as either a replacement or an enhancement to current battery systems. In electric vehicles, it can deliver fast charging power that boosts both driving range and performance. That would be good.
Yeah.
That's a selling feature.
Yep. Drones and robots may also benefit from longer operation times and improved reliability. Definitely, for sure. We're seeing how that's being used in Ukraine and Russia. Additionally, the CNT PANI composite fiber is highly flexible, allowing it to be rolled or folded for use in next-gen electronics like wearable devices.
Another major achievement of the research is the reduction of production costs and the possibility of mass production. Despite their excellent properties, single-walled carbon nanotubes have been difficult to commercialize due to their high production costs, but the researchers solved this problem by compounding them with low-cost conductive polymer polyaniline. Okay.
Furthermore, they've laid the foundation for mass production through a simple process and recently succeeded in developing film-like structures based on this technology, further advancing commercialization. Laissez-faire at its best, okay? Capital and open markets. In the future, it'll be utilized as a key enabling technology for the transition to a carbon-neutral society across various industries such as electric vehicles, robots, drones, and wearable devices.
Quote, this technology overcomes the shortcomings of supercapacitors by using single-wall carbon nanotubes and conductive polymers, says Dr. Bon-Cheol Ku of KIST. Again, quote, we will continue to develop and industrialize ultra-high performance carbon fibers based on carbon nanotubes, unquote. Okay.
Love it. Let's see where this goes.
Yep, they're on it.
Yep. The Koreans, they're at the think tank doing it.
Yeah.
All right, folks. Thanks for joining us. We'll catch you on the next one.
Take care, everyone. Thank you.